everyone, welcome back to HackCode. In this video, we're delving into the classic question that's called LeetCode 11 container with the most water. This problem requires us to find the maximum amount of water that can be trapped between the two walls represented by the array of heights. So we'll explore a brute force solution alongside a most efficient solution to tackle this problem. So let's dive in. So what's the problem statement? You're given an integer array height of length n. There are n vertical lines such that the two endpoints of the ith line are I comma 0 or I comma height of I. So find the two lines that together with an x-axis form a container such that the container contains the most water. So return the maximum amount of water a container can store. Notice that you may not slant the container. So here is an example. So basically the event is what they meant from this line is the height. Basically we are forming from here to here, right? That is the height they meant for a given wall. So this question is essentially finding the area between the two walls. So we can see that the area between the two walls is limited by the height of the minimum wall of among the two. So that's the key catch for this problem to solve. So here given the constraints is n is in the inclusive range of 2 to 10 power 5 and the elements of the array would contain in the inclusive range of 0 to 10 power 4. So where n is equal to height of the length of the height array. So here for this problem so the output is 49, that is the maximum the container the most water area is 49. How did we come at this answer? So because here the difference between the like this is the breadth and this is the height. So the L into breadth or length into breadth or height into breadth, whatever it is. So here the height is 7, the difference is 7 between these two walls. So that's how we get into 49. So let's dive into the approach, like how we get the area by using brute force. So here we can first approach is to we iterate to each wall in the input array considering it as one boundary of the container. So for each wall we iterate to the remaining walls in the array to consider the all possible pairs of wall. So for each pair of wall we calculate the area formed by the pair using the formula like min of the height of I comma j into j minus 1 where because the height is constrained by the minimum of these two walls and the into the product of like with the product of the distance between these two walls, that is given by j minus I. If we consider like this is I and this is j, we get it as the formula is like min of height of I comma height of j into j minus 1. So here we know that height of I and height of j are the heights of the wall and j minus I represents the width of the container. So we keep updating the max area with the maximum area found among all the pairs and finally we return the area found. So time complexity of this approach would be O of n square. Let's see at the code. So here we consider all possible pairs of walls and then for a given wall I we consider the next wall in the next loop. So for j in range of I plus 1 to length of height, so we calculate the area found by these walls using the formula which we just discussed. So this is basically a greedy approach. At each step we take the minimum or local maximum. That's called a greedy approach. Here this is the greedy step where we take the maximum area, and here this is not a greedy, it's just taking the minimum like we're taking the minimum of two heights, so and multiplied by j minus 1. Here it's greedy because like we at each step we consider the maximum area and then we find the answer we think the answer should be the maximum of this possible value among this we get by doing so we get the maximum area. So here the time complexity is O of n square, as clearly we can see the two loops over here where n is the height of the length of the height array. So space complexity is O of 1 since we don't use any array or list that goes with the size of the input that is height here. So O of n square is not a feasible solution given that the length of the height array can range to 2 to 10 power 5, but in a given second only a mission modern processor can handle around 10 power 8 to 10 power 9 operations. But if we take n is equals to 10 power 5, it would be 10 to the power of 10, which it can handle. So we should find a solution that's in O of n or O of n log n range. So let's look at the other approach, which is two pointer approach. So we start by initializing two pointers left and right. So we go over the loop till left pointer is less than the right pointer. If no, like if it breaks the condition, we end up the loop. We get out of the loop. So if it is in the given search range, we calculate the area between these two pointers. So if the current area is greater than the max area, then we just update the max area. If it is not, we continue without updating, and then we move the pointer the smaller height inwards. So why the intuition behind moving the pointer for the shorter wall inward is like either incrementing the left pointer if the left wall is shorter, or decrementing the right pointer if the right wall is shorter. This is based on the fact that the area is limited by the height of this shorter wall. So therefore, to find a combination of the walls that could potentially lead to the larger area, we need to find a taller wall that could serve as a new boundary for the water container. So as we move the pointer towards inward, the horizontal distance between the walls indeed decreases. This means that for the area to increase, despite the decrease in width, I mean the distance between the walls, we will have to encounter a new height that is significantly taller than the previous shorter wall to compensate for the loss in the width and still contribute to the greater overall area. So that's how the approach goes in. So each step we try to look for the maximum area. So let's go record. So this is just the approach we discussed. We initialize the max area with 0, and just this is the initialization of left and right pointers. So here, while left is less than right, we calculate the area between the two walls. That would be, we know by this time we would be aware of the formula, like what should be used. Like this was the minimum of height of left and right, and then the into the multiplied by the right minus left. This is just the breadth of the container. So we update the max area if the current area is greater. So that's what this step is about. So we move the pointer with the shorter wall towards the other wall. So in this step we compare height of left is less than the height of right, then we move the left pointer is +1, else right pointer we decrement the right pointer and return the max area. So here the time complexity is O of n, where n is the length of the height, and space complexity is O of n, where like we don't use any extra space, so that's why we have it O of 1. We just use variables here, so it's always constant, it's not changing with the input size. So it's O of 1. That by now you would be having the greater idea on space complexity if you've been following us in the last tutorials of LeetCode. So I hope you got the point why we move the pointer left +1 or decrement the right -1. That's because I'm just reiterating it again so that you get the point. So when we encounter something like if the left pointer is less than right pointer, or right pointer less than the left pointer, we always consider like we hope for the best, and so we move this pointer. So since this point, if you were there, we would be having this as a left pointer less than the right pointer, right? If let's say we are in this step here, the array of the whatever we have at the left height is less than the right height, so we increment the pointer, and that's how we got the maximum height, and then we get the maximum area with this one. So what I meant to say is, like, we look for the taller heights, like greater heights, so that's why we move, we shrink the search space. Even though this decreases the width, that whatever the height gonna come would compensate for the decrease in the width and form a maximum area. So that's the key up for this approach. So let's look into the code and execution. So here we try for the brute force first. So it's accepted answer. Let's try submitting this. We'll get TLE. I mean, time limit exceeded. This is because the input can vary from 2 to 10 power 5. So most possible thing is only 10 power 8, uh, but here 10 power 10, which is 10 power 10 operation, is not at all possible for a given processor. So we need to decrease it by at least like little magnitude. So that's where the two pointers help us. This would be O of n, so we would be having only 10 to the power of 5 operations. We'll try submitting this. So yeah, the solution is accepted. So let's get to the conclusion. So we have explored both the brute force and the optimized solution for the container with the most water problem. So by leveraging the two-pointer approach, we have drastically improved the efficiency for our solution, making it powerful tool for tracking the similar challenges in the future. So keep practicing, keep exploring, and remember, the key to master code lies in the understanding the problem and finding the elegant solution. So thanks for tuning into this episode of Hackbone. If you found this video helpful, be sure to give it a thumbs up and subscribe to the channel.